We are Group 6, and this is our project Recycling Robot. Group 6 consists of Frank, Elizabeth, and our advisor, Dr. Klink. Although the benefits of recycling are significant, many people still do not recycle. 23% of Americans do not recycle at all. Our solution to this problem is a small autonomous robot that would be able to navigate through the debris and pick up recyclable materials. This robot needs to be compact and configurable, but it has to be inexpensive so it will be widely available. Our robot has to be either self-contained or fully wireless to lower the complexity of the system. The most important part of the project is the robot's ability to recognize objects. The technology used in our project was mostly commercially available products. We produced our own voltage regulator in order to power the wireless webcam. Construction of the robot and its subsystems did not take much time. We had consistent issues with maintaining wireless communications with the webcam. The software was time-consuming though because the methods for identifying obstacles, objects, and walls were difficult to come up with without many tries. The software package we used was RoboRun. It was not the best choice for object recognition because it often crashed and had poor documentation. We also had a time constraint for working on our robot because the batteries for the robot and webcam only had a few hours capacity. The result of our project is a fully autonomous robot that uses object identification and filtering to relocate objects in a bound area. We use a wireless webcam mounted on top of the robot to aid in directing the robot around this area. In order to move our objects that we have identified around our field, we have a small arm attached to the robot. This arm has no gripping functionality, so our movements are limited, but it works for the purposes of our experiment. The robot uses filtering in order to perceive objects in its field. The program compares saved images to this filtered video stream to identify the objects that are significant. Here it has identified the target destination. As we rove around our testing area, we must be able to avoid obstacles. In this image, we combine the unedited stream with an edited version to show you what the robot interprets. This is a similar example, but instead it is looking at a wall. Wall avoidance is very important because if the robot is left unattended, we don't want it to get out of range of our communication system. The robot starts out scanning the area for objects that it can identify. Once it's found an object, it'll start moving towards it. Here you can see the robot moving towards the can in the lower left corner. Once it's gotten close to the object, it makes sure it's as close as possible and then turns so the object gets into its arm. The robot then pushes the object towards the designated area. Once the robot gets the target in the designated area, it signifies it with a beep and backs away. The robot then starts to scan the field for a new object and begins the process all over again. There's a lot we can do to make our robot more functional. A robotic arm could easily increase the functionality of the robot by allowing it to manipulate objects in its pathway. We could also expand our object database so that more objects would be identifiable. If the robot was self-charging and had a mobile user interface, it would be easier for the user to operate. Having a self-contained robot would eliminate wireless communication issues. A better webcam would make object recognition more accurate, and writing our own software would alleviate errors that cause the system to crash.